Hello, and welcome to this video on section 6.3, Forms of Quadratic Functions. As you can see, we have three different types of quadratic forms that we are going to look at today. We have standard form, which is y equals ax squared plus bx plus c, which we have looked at. And then we have vertex form, y equals a times the quantity of x minus h squared plus k. And finally, we have factored form, which was y equals a times the quantity of x minus m times the quantity of x minus n. Each of these can give us something special. In vertex form, it literally is giving us the vertex, as we can recognize that h and k will give us the vertex of the parabola, or the lowest or highest point. In factored form, the m and the n are the roots, or the solutions, or the x-intercepts of the parabola. Let's go ahead and take a look at the parabola in front of us so that we can identify more of the features on our parabola. The first thing we're going to look at is called the axis of symmetry. And the axis of symmetry is a line that cuts the parabola into two symmetrical pieces. And in a parabola, if we have the axis of symmetry, it's going to, again, be a vertical line, and it's going to go right down the middle. And I usually indicate that with a dashed line. And in this case, you'll notice that it's a vertical line. And vertical lines always have the equation of x equals a number. And in this case, our x value that it goes through is -1. Now, the axis of symmetry, because it splits it in half, is always going to go through the vertex. And as I mentioned, the vertex is the highest point or the lowest point on the parabola, depending on whether it goes down or up. In this case, you can see that our parabola goes up, and therefore our vertex is a low point at -1, -8. Note that the axis of symmetry number will always match the x of the vertex. Then we have the y-intercept. The y-intercept is where the graph crosses the y-axis. So again, the y-axis is the one that goes up and down. And so this parabola crosses at the point 0, -6. Reminder, the y-intercept will always have an x value of 0 by definition. As I mentioned, this parabola, when we look next at max and min, will have a minimum because the parabola goes up. A parabola that has a reflection over the x-axis will have a maximum. The minimum or the maximum is the y value associated with the vertex. So our min, in this case, our minimum, is at -8. In other words, -8 is the lowest y value on the graph. Now our x-intercepts are the places where the parabola touches or crosses the x-axis. Our parabola crosses at 2 points. It crosses at -3, 0, and at 1, 0. And I'm listing these as ordered pairs. Just be careful that if you list them just as -3, 1, you would not want to use parentheses, but rather solution brackets. Now, we can identify lots of points on the parabola, but I'm just going to show you that in particular, because of the symmetry, we can identify a point using the axis of symmetry. We see that the y-intercept is 1 to the right of the axis of symmetry, and therefore there is also a point that is 1 to the left of the axis of symmetry. So I'm going to list that here as -2, -6. All right, so now let's go ahead and identify the domain and range. We know from our previous studies that the domain of a parabola is always negative infinity to positive infinity, or all real numbers. We can put any x value into the function, but we won't be able to get a range of all real numbers. The range is going to be limited by where the vertex is. So just as a reminder, I'm just going to draw a little line here. We want to think about the y values as our down to up, and therefore we're going to use -8 as our lowest or our minimum, and it keeps going to infinity. So again, our range would be -8 to infinity, and it includes -8 because we have a coordinate there. All right, so now that we've identified some key features, we're going to actually learn how to write the equation of the parabola in the various forms. So the first one we're going to write is number 1, which is the equation of the parabola in vertex form. So again, a reminder is that vertex form is when we have y equals a times the quantity of x minus h, quantity squared, plus k, where our vertex is the ordered pair hk. Well, we know from what we've already looked at that our vertex is the ordered pair -1, -8. What we're missing is knowing the a term. So we are going to actually plug in the a point on the graph and the vertex to evaluate or determine what our a term is. So we know the vertex is -1, -8, and we also have another point on the graph. And let's see, I'm going to use the y-intercept, so I'm just going to match that color up here. We know that there's a point 0, -6. So what I'm going to do now is I am going to use the point 0, -6 and plug that in for the x and for the y in the spaces that they belong. And then I'm going to plug in the vertex. -1 is our h value, and -8 is our k value. And then that allows me to solve for the remaining variable, which is the a term. So let's go ahead and get started. If I plug in the y value of -6 here, I don't know my a term, but I know an x value is 0 when I take the point that I've identified, minus a -1 becomes +1. And then I'm going to plug in the k value, which is -8. So now I'm just going to evaluate and find the a term. So again, I'm going to follow order of operations. In the parentheses, minus a -1 is +1. And when I square that, I get 1. So now I have a times 1. And that is just going to give me a minus 8, because a times 1 is a. And when I add 8 to both sides, I find that the a term is 2. So I'm now going to put that all together in my vertex form. I'm going to leave the y and the x, but put in the h, k, and the a. So here we go. Y equals a, which is 2, times the quantity of x minus a -1, which is +1, quantity squared, minus 8. And now we have our vertex form. All right, so now that we've looked at the form, it's easy, or at least I hope it is, to look at our graph and figure out which one of these matches with what we just did. So we can see that it matches with b, which is f of x, or y, equals 2 times the quantity of x plus 1, quantity squared, minus 8, because we just put it into vertex form. All right, so let's move on to how we would do that if we wanted to put it into factored form. Now, we're going to pretend that we didn't just solve for the a term and that we don't know the a term. So if we were starting from beginning again, and we wanted to write the equation of the parabola in factored form, just to recall, factored form is going to be this y equals a times the quantity of x minus m times the quantity of x minus n. So again, we need to know the a term, and in factored form, we're going to be using our x-intercepts for our m and our n. So we know that our x-intercepts are -3 and +1, and so those are the numbers that we're going to be using for our m and n. All right, so let's go ahead and look at how we do that. So I'm first just going to write the form y equals a times the quantity of x minus m times the quantity of x minus n. And we can say that our m is equal to -3 and our n is equal to 1. Those are interchangeable, so we could have made the m 1 and the n -3 and it will still work out the same. So just as we did in the factored form, or the vertex form, excuse me, we can also pick an xy coordinate. It can be a point, a different point, but I'm going to go ahead and choose the y-intercept again. And let me just do that in a different color so we can see what that looks like. So again, we said the y-intercept was at 0, -6, and that's going to be a point on the parabola. And so we're just going to identify where those go in the factored form. So again, we're going to use x of 0 right here and here, and a y of -6, and then we're going to replace our m value with -3. And notice that I'm not highlighting the negative right there because we're going to do minus a -3 for that. And we're replacing the n with 1. All right, so here we go. Again, we're pretending that we don't know what the a term is. So, oops, I did not mean to write y. We're going to now put -6 is equal to a times the quantity of 0 minus a -3, which becomes +3. And then we're going to use 0 for our x value again, -1. Now, what happens is, in this first parenthesis, 0 plus 3 is 3. And in the second parenthesis, 0 minus 1 is -1. So when I multiply a +3 and a -1, I get -3. And again, we usually see the number in front, so I'm just going to rewrite that as -3a equals -6. To solve for the a term then, we would divide both sides by -3, thereby giving us the a term of +2. Now again, I wouldn't expect you to do this if we already knew the a term, but you can see how we are solving for it by plugging in both a point on the parabola as well as the x-intercepts that are the m and the n. And so now we're going to put it all together, and we're going to say y equals, because we always want to have the y and the x values as variables, equals 2, and then we're going to use x minus a -3 or +3, and then another parentheses, x minus 1. So this would be the factored form, or we could replace the y with f of x. All right, so now we have our final form. We're going to write the equation of the parabola in standard form. And as a reminder, standard form is when we have the equation in y equals ax squared plus bx plus c. And just as a reminder, the a term is the same in all three of these forms. Okay. So if we have, we're going to start first with, I'm just going to kind of split this down the middle. So we're going to work first, if we have vertex form that we know, then we can go ahead and, let's go ahead and write the vertex form. It's 2 times the quantity of x plus 1, quantity squared, minus 8. We could just evaluate by actually multiplying x plus 1 quantity squared out. So remember, that means that we would be FOILing x plus 1 times x plus 1. And if we FOIL there, let's go ahead and just kind of remind everybody that we're going to get x squared plus 1x plus 1x plus 1. And then we would simplify everything in the parentheses by combining our like terms to get x squared plus 2x plus 1. Now, let's go ahead. I should have carried down the y equals. Sorry about that. Now let's go ahead and distribute the 2 into the parentheses and get 2x squared plus 4x plus 2, and then minus 8. When we combine these like terms, our final answer in standard form would be y equals 2x squared plus 4x minus 6. So again, simply following order of the operations, we can go from vertex form to factored form. Now let's do, vertex form to standard form. Finally, let's go ahead and go from factored form to standard form. So in factored form, we came up with y equals 2 times the quantity of x plus 3 times the quantity of x minus 1. So again, we're going to be FOILing the x plus 3 and the quantity of x minus 1 and then distributing the 2. So here, we're going to get x squared minus 1x plus 3x minus 3. Now again, I'm going to simplify the parentheses first. And that's going to give me, when I combine my like terms of negative x plus 3x, that's going to give me x squared plus 2x minus 3. And then finally, distributing the 2, the a term, to each of the 3 terms, I end up with y equals 2x squared plus 4x minus 6. So you can see that we got the same answer going from vertex form to standard form, and then from factored form to standard form. This concludes our video on section 6.3, Key Features of Quadratics. We've covered quite a bit in this video, so please look it over and come to class with your questions.